Well, hello. Good morning, everyone, and thanks for joining us in this session. We know we're here, why we are here. Most probably you have Windows workloads running already on AWS, and we're here to help you run those workloads more securely. Security is just a broad topic. You can't really cover everything about it in one session, two sessions, let alone a whole summit. But we can give you some tips and tricks about running those more securely, and that's what we're going to do for you in this session. There's going to be lots of demos, so we're just going to dive into it. My name is Hassan Hajrasuliha. I'm a specialist solutions architect with AWS, working with SLG customers, and my main area of specialties are Active Directory, security, and infrastructure based on Microsoft workloads. Later on, I'll be accompanied by my colleague, Sean, who will talk more about the compliance part of this stuff. Our agenda today will show you in action how you can actually use our products and offering to harden your security images, then administering them using the systems manager, and later on, Sean will take over and talk about the other offerings you have that you can use for your compliance requirements. So, building and deploying security hardened images. As we know, imaging is part of the routine thing that you do to actually deploy your servers securely and efficiently. Many of you have built and maintained your golden images that conform to your organizational and industry requirements across AWS and on-premises. You do this either by manually doing it all over, or by building and maintaining some sort of custom routine, semi-automated methods and technologies, or you will use some custom automation scripts with open frameworks like Packer, for example. We know they work, and we know customers spend a significant amount of time working on those with this technology. Same thing happens with the cloud. When it comes to preparing your images in the cloud, you have multiple options out there. One option is to just continue doing it manually. You go to this website, you download the configuration they put out there, you use some tools. For example, in this screenshot, I have the Microsoft Security Compliance Toolkit. You can use that to execute those settings on the base image and come up with the hardened image. It works, but as a customer-obsessed company, we just keep listening to our customers. And these are the pain points that you, as customers, have shared with us. You want something automated, because human errors just pop left and right. It will be time-consuming. You want to be able to test them routinely. Again, something will always fall into the cracks if you don't have proper testing. Security will be compromised if those routines are not implemented properly on the images. Distribution and sharing of the images will become a hassle on their own if you don't have a good method for that. And naturally, you just want one set of tools to work both on-premises and on your AWS cloud. And our answer to that is Image Builder. It's an offer that has some sort of CI/CD mentality that you usually see when it comes to deploying the software in your infrastructure, but we put that into the infrastructure deployment and maintenance context. We let you create automated pipelines as part of the Image Builder, minimize unnecessary security post-share as part of that because everything is automated, and we have the validation routines built into Image Builder as well. It works both cross-premises, it works for both Windows and Linux images, and because it's part of the AWS, you get those audit and controlling capabilities that you get as part of AWS organization. You can limit access, you can audit access, and have all those feature sets in Image Builder. How it works? It's actually quite simple. You start with the base image. That base image can come from AWS, or it can be a custom image that you import into AWS. You keep installing and configuring pieces of software on your base image, harden that, test that, and then distribute that. in more details, you get your source image, you get different steps or elements which are going to transpose your source image into your target image called components. You have the build components and you have validate components. And once you're done, you can define test components for your process as well. And this combination of different components on different stages is going to make what we call a recipe. So you get the source image, you apply the recipe to it, you get into your target image. But that's not all it does. Once you have the recipe, now you will define the infrastructure on top of which you want to test your image. Think about scenarios that, hey, for my image to be validated, I need to be able to ping the other server on my infrastructure to get, I don't know, a reply back or even an HTTP ping to get a 200 OK response, something like that. So those elements you can also define as part of your infrastructure configuration. Or, I don't know, this image that I'm building needs a GPU instance for it to work properly. So you have to define the instance type as part of your infrastructure as well. And that's what infrastructure configuration will let you do. Distribution, whether it's going to be staying only in my region, I'm going to distribute it in my DR region, different accounts who's going to be able to use that image. All of those are part of your distribution. And then finally, how often I want this process to repeat itself. Every month, every 2 months, every Patch Tuesday. All of that is something that you can schedule as part of your definition of your pipeline. And then eventually, you will get your image. And this is how it works in the background. Whenever you run your pipeline, we create an instance of your base image. We download all those components, build and validation components. Once we're done with that, we sysprep it. We generate a temporary image. I mean, it is your final image, but it's still marked temporary because we need to test it. And when it comes to testing, we use that image we created, spin up another instance off of it, run those test components against it, and if all those tests came out successful, at that point, we mark the image as valid, and we just destroy that test image. And let's see that in action. Can we get the volume higher up? Until they figure out the audio, so it is a dashboard for EC2 image builder. We're going to create an image pipeline. Just going to name it. Okay, there's a pause here. So this is a place that you define your schedule for your pipeline, how often you want your pipeline to run. GUI there, cron expression for those Linux guru guys. And in my demo, we're going to just run it manually. Best practice to tag your resources. So we're just using the purpose tag here. It's completely optional. So the steps or the components we're going to install, they will be bundled as the recipe. And that's how we define a new recipe. You can reuse the recipes you've already defined as part of many pipelines. That's what we're doing We're giving it a name. There's a versioning element for your recipe. This is how you define which image to use as the base for your pipeline. In my example, we're going to use just Amazon Managed one and the ones that you pick up in the quick start menu when you log into your console. By the way, I don't know if I mentioned this or not. Everything you see is actually demoed in the GovCloud. So what you see is what you get if you're a GovCloud customer. And almost everything that we have on GovCloud is doable on the commercial cloud as well. The other way around is not necessarily true. So I picked up my base. There are user data. You can include optionally as part of your base image. And user data is the same user data concept that you have for your EC2 instances. Some built-in components you see here. You can create your own components, component to install software A or software B or do this testing. These are the pre-built ones. For this demo, I picked Kinesis agent and CloudWatch agent. But this is where our real demo is. Our purpose here is to create stick compliant images. And that's what we're going to do. We search for stick. As you see, there are 3 severity levels defined for you on AWS Cloud. We have the documentation out there showing you what each of these compliance levels mean. High, medium, low. There is a spreadsheet out there that explains what we've implemented at each level. And then, of course, referral to the external stick document library. You'll get a link to all this documentations as part of this slide deck later on. But the information is there. So I'm going to choose to harden it with the high severity level. And something we always recommend is to run the runbook to make sure your image is getting the most recent updates as well. Here, you define the order at which you're going to implement your build and validation components. So I always want the stick component to be the last one because we've seen it. Sometimes when you run an update or a patch against the machine, they might tweak the registry settings back and forth and kind of drift it from the compliance hardening that we want it to be. Same thing after that for the testing components. On this demo, I'm just going to pick this simple test. As long as my machine reboots, it means that it's a good image. The the EC2 instance type that I'm going to use for my build and test. Again, optional tagging. Recipe defined, schedule defined, infrastructure piece, which VPC I'm going to use it for. Sorry, the demo is paused. Are you guys working on it? Can you unpause the video, please? anyways, let's move on to the next video. I mean, you define the infrastructure, you define the distribution, and it will just run. On the next one, actually, this one's completely, sorry for our technical difficulties here. Okay, we're back. It's not working, no. If you can play this one, this is the actual next piece of video. Okay. So in this part, I mean, you let your pipeline run. It usually takes like 20 to 40 minutes for the image to get built up. On this one, after we're done with the pipeline, I'm going to show you what it has done to the image itself. We're going to connect to the image, and we're going to test it with Microsoft tools to compare it with this baselines that is pushed out there, and we want to see how compliant we are compared to its settings. That's pretty much what this piece of demo is about. RDPing to that instance that we created out of that image. As part of the stick hardening playbook, we actually installed the DoD PKE in your image as well. So you can get your root certificate installation out there as well. While it is working in the background, we're going to get into the actual tool. You remember, as part of our build and validation phases, we chose the CloudWatch and a Kinesis agent. They are there, so those pieces work fine. These stuff I downloaded off of this website. As you see, they've pushed out GPO configuration for all those products. Windows servers, different version, Office, Adobe, and those ones. So my image is a 2019 image, so I'm going to compare what I have with what their recommendation is in terms of hardening. And the tool I'm using is Microsoft Tools for Security Compliance Toolkit. Okay, that root CA tool got finished loading. We don't need that. What I'm doing here is to just start everything fresh. At the first step, I'm importing the settings from this into the tool to be my baseline for comparison. Moving to the folder, GPO. It just imports all the settings. And this is how the tool works. You have to define a temporary place for it to just do all the compilation and summary. Then there's the compare to effective state. That one loads existing configuration from my image. And the GUI is a little bit iffy on the higher resolution. Apparently Microsoft needs to revise this part. And here's the comparison. We have the baseline, and then we have the effective state. This is how we want it to be. This is how it is now. But now it has the settings for domain controllers as well. This machine that I'm testing it against is not a domain controller. So I'm just unchecking the settings that are out there for domain controllers. So now, as you see on the top, I have items listed as 173 items that we need to address. We're still running into some difficulties again.
Now we're down to 173 items. Out of those, I want to see baseline are those that we imported
now
from
we have the
Dissel's
actual audio.
recommendation, and effective is what we have as part of the image builders. So we come here, we check it to show only the differences. We're down to 30 items.
So out of those 173 items, I wanted it to show me only the drifts from the baseline. And as you see, the tool detected only 30 drifts. But we're going to take a closer look at these drifts as well. So for example, for this one, the logon count. I mean, every environment modifies that based on the requirement. They're not going to mimic exactly what this is telling them. Or for example, the reason that the tool picked up these two items, the login text. Naturally, as AWS, we're not going to enforce any type of logon caption for you. You will define it for your image. Or for example, this one. That one is actually a templatized setting. It says put your share here. When we go further down, you will see other settings that it says put your admin there. And that's the reason the tool picked it up. So the actual number of drifts is even lower than 30. So we already took care of over 140 compliance settings that was required for your images to be DISA compliant. I guess we can move forward off of this demo, if I can get it moving past on. Remember I told you have multiple options? There's an option 3, running an SSM command against the existing EC2 instance that you have. The demo is just a screenshot here. You would go to the SSM console, you pick up the stick document, and you run it using the run command. And option 4, I don't know if you guys will hate me after this or no, but we have already done it for you. When it comes to hardening the base image, it's already there in the marketplace. It's not in the quick start section, but it is actually in the AWS marketplace. You scroll it down, you find out it is actually published by Amazon Web Services. You can simply pick that. But the reason we brought up this whole image builder thing is that you needed to have a pipeline to be able to do this as part of the other routines you need to make your stick compliant image. But when it comes to just hardening the OS, just pick it up from there. That was it. That was our first topic. The second topic I wanted to talk about is administering your EC2 instances securely. We all know that opening your RDPs wide open to internet is just a recipe for disaster. This one is just one of the many, many you can find on the internet. Happened on August. It's odd that it says AWS instance, but it can happen to any open RDP instance, on-prem, our cloud, other cloud. It's just folks that are out there who are trolling and brute forcing that. We have a broad set of management tools from the different management and operations step of your IT requirements, CloudFormation to spin up your infrastructure, CloudWatch to monitor that, a lot of other options that you see out there. The one that we're focusing in our demo today is the Systems Manager, which itself is just a combination of different mini services, if you will. Fleet manager, the fleet management, inventory management, all those that just comes under the title of node management. Then you have other ones for operation and application management. As an example of that is our patch manager, is the service that will help you get insight into your patch level on your EC2 instances. As you see, you'll define a baseline depending on the tags, patch groups, operating system, and so forth for your EC2 instances. We compare it against the baseline. We will give you a report of the compliance, and we can actually help you bring them up to compliance by actually patching the instance. And the one that we're going to show you a demo of is Session Manager. It's a service that will help you use the AWS infrastructure to connect your instances securely and manage those. It has, as you see, single solution for privileged access across Linux and Windows. It works for both SSH, PowerShell, and as you will see, the actual RDP instance. Centralized access to IAM, so all those controls that you have for your services, it can be there. It is there. You can control it with IAM. You can have audit policies imposed on that. And not only that, even it's optional for you to make sure that all the IOs that happens with the machine is actually saved in an S3 bucket. So you can see what your operator has typed in and what was the output. You pretty much get a replay of all the text that you get on the terminal console. And the thing that we're going to show you is how you can leverage this to RDP into your instances without exposing RDP to anywhere, really. As we talked about, all you need to onboard your instances into Session Manager is just making sure the endpoints are visible to the EC2 instance, and the instance has proper IAM roles assigned to it so that it can actually call the APIs of SSM, and that's about it. Some session of it will be stored in Session Manager. As I mentioned, optionally, you can have all the outputs put in S3 and CloudWatch logs. The port forwarding feature or the tunneling feature of that, it works in a way that you will install a little component on your own workstation. It will get all the packets on that specific port that you define, and then later on, it will use the channel that it already has with the SSM infrastructure to deliver that packet to the SSM agent, and we kind of use this bridge to connect to your instance. As a result of that, we don't need any direct visibility into your instances, so you can just lock down your instance from external traffic, and you still have the communication as long as you have those features set. And hopefully this demo will go glitch-free.
Okay, now we're going to show you how you can leverage Session Manager to connect to an isolated instance. Let me show you what we have here first as our infrastructure for this demo. In my VPC console, as you see here, I have one VPC that I've created for this demo, Summit Private VPC, VPC ID 05C1. This VPC doesn't have any sort of internet gateway, doesn't have any public subnets, no NAT gateways, there's no VPN connection to connect it to the outside world, nothing. I mean, we can take a look at the routing table that's assigned to this. This one is, okay, the first one is the one that's assigned to that subnet. Only the local traffic is allowed. If I go to internet gateways, there is no gateway attached to that VPC as you see here. Same thing for NAT gateways. I don't even have one in my account set up. Security groups, 0C5, 05C1, so that is the one. If, as you see, only the local traffic is allowed. So there is absolutely no outbound traffic allowed on this VPC. This is completely black holed, for the lack of a better term. What I have this on this VPC though are, first off, the endpoints, the private endpoints for SSM that will let SSM services to be run on a private subnet. And we have a full documentation on how to enable this. And on top of that, I have the Route 53 enabled on this. So you would come, you would edit DNS resolution on this VPC, and you have to make sure that this checkbox is enabled so that Route 53 can be used to resolve names on whatever instance that you have eventually on this VPC. Having that, what it means that if I actually put an EC2 instance on this VPC, it will not have any connectivity to the outside world whatsoever either. And that is exactly the case. What I have here is a private instance that I've put on the same VPC. As you see, it only has a private IPv4, a 10 dot. In that region, no IPv6, no public IPv4. It's completely segregated from any environment for that matter. However, I want to be able to manage this. For those, as a result of that private links that I've created for this VPC, this private instance can securely communicate with SSM. As a result of that, when I go to connect, the session manager is active here, and I can simply use connect. And voila, I have a full PowerShell. It shows me that I'm running under the SSM user. Pconfig that 216 that we saw at the console. Route 53 is working, so I have the name resolution, but I don't have any route to the public internet, so naturally this ping request will come off. And all of this optionally can be put down on an S3 bucket, so that later on when you go to that S3 bucket, you would see all this console, whatever I typed in, whatever the output was, as part of the S3 log. So that was Session Manager. However, that was not our main thing in our demo. We wanted to actually RDP into this instance here. So what do we need to do? Let's use the content on this blog that we have here for the tunneling feature of the SSM. You'll get a copy of this resources as part of the slides as well. I have to run this simple line. I have to have the command lines installed on my machine, on my local workstation, and I have to have the Session Manager plugin for it as well. Let's bring up our command line. First off, configure list -profiles. So I have two sets of credentials, one for my commercial region and one for the GovCloud. This one is for my GovCloud. I'm going to use this name in my later commands. So AWS SSM to go into SSM context. Start session. Dash profile. It will be this one. And the target will be this instance ID that I have here. Let's run it like that first. Starting session, same PowerShell session that I saw in the console. Now I have it on my terminal. But this is not what we wanted, so we run the same command line. This one, we're going to add some other parameters for the tunneling. As you see, the parameter here is --document-name. So we're going to add that.
Don't forget about case sensitivity. One of the reasons that I'm actually copying and pasting is that I run it multiple times, each time with just one case sensitivity off, and it would just fail.
So document name is start port forwarding session. What I'm telling it to do is to any traffic that comes to my local port, whatever, 56789. In this example, I want to forward it on the remote instance on the port 3389. Naturally, all of that is TCP. So now let's take a look how it will work out. So starting session, waiting for connection. Apparently it says port 56789 open for this session. So now my local workstation is waiting for a connection on that point. Let's see if that works. I will start a remote desktop session. I will tell it to connect to local host. My port was 56789 from the previous test. I already have it. Connection accepted, and as you see, I have a pop-up for my password. Okay, I already grabbed it. And voila. It says localhost, but through the tunneling feature of SSM, now I'm connected to that instance, which already I, by the way, created it from an stick image, so it has all those stick feature sets as well, but is completely isolated from my environment. So if we take a look, ipconfig ping just for the, I don't know, it's coming up with.
And that was really our key point. I mean, always put some sort of proxy between yourself and your RDP target. And in this demo, your proxy is the whole AWS infrastructure. It would be a little bit challenging for the hackers to hack into that. Keep that one in mind. And with that, I actually pass it to Sean. I took a lot of your time.
Thanks,
already.
Hassan.
Sorry for that, man.
Appreciate it, no worries. All right, so today I'm going to talk about meeting higher levels of accreditation like FedRAMP High and Department of Defense Cloud Computing Security Requirements Guide for impacts level 4 and 5, and how you can achieve those with AWS. So AWS GovCloud US is where you can deploy your workloads to achieve these higher levels of accreditation. GovCloud is isolated AWS infrastructure and services for customers with strict regulatory and compliance requirements and sensitive data. AWS GovCloud US regions are built and operate to meet the same high security and compliance requirements as all other AWS regions, while also addressing specific US federal government requirements designed to protect controlled, unclassified information, personally identifiable information, export controlled data, and other forms of sensitive information. The origins of GovCloud dates back to more than a decade ago when customers, particularly in the US public sector, became interested in understanding how they can migrate and architect workloads in the cloud to meet their highest levels of compliance and regulatory requirements. AWS needed a way to enable the US government agencies and commercial organizations in heavily regulated industries like aerospace, defense, finance, energy, and healthcare to move sensitive and regulated workloads to the cloud. To support these customers' unique requirements, we built the first AWS GovCloud US region in 2011, AWS GovCloud US West. We continued to see growing demand from these customers as more organizations moved more workloads to GovCloud, and launched the second AWS GovCloud US region in 2018, AWS GovCloud US East. AWS GovCloud US offers customers secure, compliant infrastructure as a service and services purpose-built for sensitive data and regulated workloads that power their mission and business-critical capabilities. We also give them the tools and resources to accelerate their time to compliance. Our goal is to enable our customers with the highest bar in terms of regulations and compliance while using AWS and AWS GovCloud. So there are a few requirements you have to meet in order to gain access to AWS GovCloud US. The root account holder must be a US person, i.e. a US citizen or a green card holder. The organization must be a US entity and based on US soil. And both the customer and the business must not be barred from handling export control data. So fundamentally, GovCloud is all about compliance in the cloud. These compliance frameworks and regulations represent the core requirements GovCloud is built to address. Essentially, they govern the security policies and controls that agencies, contractors, and organizations and regulated industries are required to abide by to secure controlled, unclassified information and regulated workloads. So first up, we have the National Institute of Standards and Technology, or NIST. This establishes many of the underpinning of policies, practices, and procedures that are on this chart. NIST special publication, So NIST Special Publication 800-53 pertains to government systems and data and guides for how customers can abide by FISMA requirements. NIST Special Publication 800-171, a subset of 800-53, controls that pertain to non-government data centers and environments like aerospace, defense, energy, etc. Up next, we have FedRAMP. FedRAMP is the security and control framework for the federal government that allows customers to meet FISMA requirements in the cloud. GovCloud meets FedRAMP moderate and high requirements. FISMA is an act that was enabled in 2002 that governs how US federal entities secure and protect information systems in their environments. Up next, we have the Department of Defense Security Requirements Guide, or DoD SRG. So this is similar to FedRAMP, but with specific controls for the Department of Defense. Customers can architect for impact levels 2, 4, and 5. IL5 specifically allows DoD customers to run their most sensitive, unclassified workloads in the AWS cloud. Up next, we have Criminal Justice Information Systems Security Policy, or CJIS. This is governed by the Department of Justice and pertains to protecting law enforcement data information systems. Up next, we also have DFARS, or the Defense Federal Acquisition Requirements. Is an extension of the Federal Acquisition Request, FAR, that focuses on defense contractors for the DoD. It comes with a number of compliance requirements and around incident response and compliance. Two more, we have the IRS 10-75, or -1075, and these apply to customers with federal tax information, sensitive information about tax holders. And last, we have ITAR, or International Traffic in Arms Regulation. ITAR governs the import and export of defense and military articles found on the US munitions list. So FedRAMP is all about addressing FISMA requirements in the cloud. AWS has infrastructure and services that address the FISMA high baseline, which consists of 421 security controls with NIST 800-53 as the foundation. GovCloud gives customers a platform that they can use where they inherit a majority of their controls, leaving responsibility of the application tiers to their customers. All right, so we said we have a lot of different services that help you meet your compliance, right? So currently, an event has occurred. So you've received an alert from Amazon CloudWatch that you have a new administrator user in the AWS IAM console that does not have multi-factor authentication set up. Amazon CloudWatch gives you complete visibility of your cloud resources and applications to collect metrics, monitor log files, set alarms, and automatically react to changes. Next, as we start to investigate, we can use AWS Security Hub to help us understand our overall security posture via a consolidated security scores across all of our AWS accounts. We can automatically assess the security of our AWS accounts resources via the AWS Foundational Security Best Practices Standard and other compliance frameworks like the CIS benchmark. So now we have to investigate. By drilling down into the finding in AWS Security Hub, we can select Investigate on the example admin user. Once we select Investigate, we are navigated over to AWS Config. In AWS Config, we can see which rules are not in compliance, and we can even set a remediation action to auto-remediate this further. But before we do that, we should investigate more to see who created this new user and if they have even accessed the environment. So using AWS CloudTrail, we can check to see who created the new user account and if they have ever logged in. Using AWS CloudTrail, you can track user activity and API usage to enable governance, compliance, and operational or risk auditing of your AWS account. And finally, we have a few options we can use to try to remediate this finding. We can try to auto-remediate this finding with AWS Config. We can reach out and ask the administrator to log in and enable multi-factor authentication on their account, or we can delete this user if it is no longer needed or created an error. The last topic I'd like to discuss is our Authority to Operate, or ATO, on AWS program. Authority to Operate, ATO, on AWS is an AWS partner network program which provides resources to solution providers running on AWS who need assistance in their pursuit of compliance authorization. This includes the Federal Risk and Authorization Management Program, FedRAMP, Defense Federal Acquisition Regulation Supplement, DFARS, Payment Card Industry Data Security Standard, PCI DSS, Criminal Justice Information Services, CJIS, and many other compliance programs. ATO on AWS is a set of resources including automation, templates, and best practices that help solution providers running on AWS accelerate the security and compliance authorization processes, reducing the time and costs it takes to achieve an ATO, such as FedRAMP or CJIS. This is achieved by providing resources that help. This is achieved by providing resources that help solution providers build, implement, and optimize DevOps, SecOps, continuous integration, continuous development, delivery, continuous risk treatment, CRT strategies, and processes for their organization. Additionally, ATO on AWS provides access to managed solutions that minimize the level of effort required to achieve such authorizations. And on that note, I challenge you all to, if you do not already have an AWS account, to set up an account and get started today. We have lots of tutorials available. We have blogs, white papers, walkthroughs, all of those kinds of things, as you've seen. So we challenge you guys to get started today.
So resources, as we promised, later on, all the documentation that you saw here, we have listed here for you to pick up, some third-party links as well. And with that, we lost most of the time for Q&A, but we'll be here in the session for you to talk to any questions we have. Give us a survey. I know we had some technical glitches here, but hopefully it was helpful for you and you got something out of that. How much time do we have?
We can take another few minutes for Q&A.
Of course. Then go ahead.
Anybody have any questions? If so, please step over to a microphone.
I have a question about the ATO on AWS partner program. You had the average time at 18 to 24 months. Hopefully that was without a partner.
Correct.
What is the average time with a partner, and how would I get in touch with a partner?
I'll take your information. I can get you the information for the ATO program and put you in check. Depending on how far along you are in your compliance journey, they do help accelerate that. They have a lot of documentation, quick starts, those kinds of things that they can provide you to help you get started, but it accelerates it quickly.
So that was a really interesting discussion and demo. I was amazed that the RDP thing actually.
I'm glad.
That help an agency that is trying to move a workload sort of understand where they need to be and what services, whether it's CloudTrail or Security Hub or whatever, that they should be utilizing. Is it all under security automation orchestration? Like, what's the center of gravity for that stuff?
So a lot of it rolls around compliance, right? So knowing whether you need to be at IL 2, 4, or 5 will generally be the data, right? So whether that's controlled, unclassified. But we also have our DoD compliant framework, which is a quick start, which helps you deploy that quickly, and that will help you get to IL 4 or IL 5. It's not a complete solution, right? You have to still add next-gen firewalls, your own antivirus, but you can use tools like AWS Security Hub to assess your security standards or Nessus, right? So it's really a quick start to help you get the infrastructure and networking in place to deliver that. And then on top of that, right, we have professional services that can help deploy that. We have partners that can come in and help with that. And then, as always, you're going to have to get a third-party assessor if you're doing FedRAMP or those kinds of things. So,
Yeah, okay, thanks.
no problem.
Of course.
Sorry, we're a little bit short on time, but please feel free to get with our speakers afterwards and ask them questions directly.
Yep, we'll gladly
Many thanks.
meet with you guys outside. Thank you.
Thanks for your participation. Appreciate it.